Problem 1. Solve the simultaneous equations using Cramer's rule. 2x plus 5y equals to 9 and 2x plus 3y equals to 7. So, you are given 2x plus 5y equals to 9 and 2x plus 3y equals to 7. And we are required to determine the value of x and the value of y using Cramer's rule. But what is Cramer's rule? Suppose you're given equations a1 x plus b1 y equals to c1 and a2 x plus b2 y equals to c2, and you're required to determine the value of x and y using Cramer's rule. Let's call this equation 1 and this equation 2. They are both linear equations, and from linear to matrix form or compact form, this is the same as a1 b1 x equals to c1 and a2 b2 y equals to c2. Let's call this equation 3, but this is of the form a times x equals to b. It's a system of linear equations in compact form, where a is the coefficient matrix series, and x is the vector of unknowns is, and b is the vector of constants this. X and b are also matrices because a vector is a matrix with any number of rows but with one column. But from Cramer's rule, the required value of x will equal to dx divided by d, and the required value of y will equal to dy divided by d, where dx, dy, and d are determinants. But how do we obtain these determinants? From equation 3, we've seen that a equals to a1, b1, a2, and b2. And x, vector x equals to, or matrix x equals to x, y, and matrix b equals to c1 and c2. But from matrix theory, a determinant is obtained by subtracting the product of elements on the minor diagonal from the product of elements on the major diagonal. So for this matrix A, determinant A will equal to product of elements on the major diagonal, which is A1 times B2, minus product of elements on the minor diagonal, which is A2 times B1, and this will equal to D. This will give us the value of D. But how do we obtain the value of dx and dy? To obtain the value of dx, we have to have a matrix Ax. So for matrix A, x, it will equal to obtain the matrix Ax, we modify this matrix A by replacing the coefficients of x from the linear equations, which is A1 and A2, with the elements in B. So this will become C1, C2 instead of A1, A2, but we maintain B1 and B2. So from this, let's obtain the determinant. So the determinant of Ax will equal to product of elements on the major diagonal, which is C1 times B2, minus the product of elements on the minor diagonal, which is C2 times B1, and this will equal to dx, will give us the value of dx. Also for the determinant dy, let's get to the matrix Ay. which will equal to obtain the matrix AY, we modify the matrix A by replacing the coefficients of Y from the linear equations, that's B1 and B2, with the elements in B, or the elements in the vector of constants. So we will have A1 and A2 will be maintained, but B1 and B2 will be replaced with C1 and C2. And from this we can obtain the determinant. So the determinant of A, Y will equal to product of elements on the major diagonal, which is A1 times C2 minus product of elements on the minor diagonal, which is A2 times C1, and this will give us dy, the determinant dy. So after obtaining the determinants d, dx and dy, our value of x will equal to dx divided by d, and the value of y will equal to dy, determinant y divided by determinant d. Okay, let's try to apply this knowledge in solving the given problem. So from the problem, we were given 2x plus 5y equals to 9 and 2x plus 3y equals to 7, and we were required to determine the value of x and the value of y using Cramer's rule. So let's call this equation 1 and this equation 2. From linear to matrix form or compact form, this will become 2, 5, 2, 3. This is x and y, and this is 9 and 7. Let's call this equation 3. But this is of the form, it's of the form a times x equals to b, which is a system of linear equation in compact form or matrix form, where a corresponds to this coefficient matrix and x corresponds to this vector of unknowns and b corresponds to this vector of constants. But from Cramer's rule, the required x equals to determinant x divided by determinant d, and y equals to determinant y divided by determinant d. But from equation 3, matrix A corresponds to 2, 5, 2, 3. Matrix X corresponds to matrix of unknown or vector of unknowns, which is x and y, and matrix B corresponds to 9, 7, which is the vector of constants or the matrix of constants. So let's obtain the determinant for A. But from matrix theory, determinant is obtained by subtracting the product of elements on the minor diagonal from the product of elements on the major diagonal. So determinant of A will equal to product of elements on the major diagonal, which is 2 and 3. This is 2 times 3 minus product of elements on the minor diagonal, which is 2 times 5. And this will equal to 2 times 3, this is 6. 2 times 5, this is 10. And 6 minus 10, same as negative 4, which equals to determinant d. But how do we obtain the value of dx and dy? To obtain the determinant dx, we have to be having a matrix Ax. But how do you obtain the matrix Ax? The matrix Ax is obtained by modifying the matrix A. And this is done by replacing the coefficients of x in equation 1 and 2 by the elements in matrix B or in vector B. So this will become, instead of 2 and 2, we'll have 9 and 7, and we maintain the coefficients of y, which is 5 and 3. And from this, we can obtain the determinant. So the determinant of AX will equal to the product of elements on the major diagonal, which is 9 times 3 minus the product of elements on the minor diagonal, which is 7 times 5. For this, 9 times 3, this is 27, and 7 times 5, this is 35. But 27 minus 35 is the same as negative 8, which will equal to determinant x. Also for AY will equal to, you obtain AY by modifying matrix A. But how do you modify matrix A? This is done by replacing the coefficients of y from equation 1 and 2 with the elements in matrix of vector of constancy B. So this will become, we maintain the coefficients of x, which is 2 and 2, but replace the coefficients of y with the elements in B, which is 9 and 7. And from this, we can obtain the determinant. So the determinant of A, y will equal to the product of elements on the major diagonal, which is 2 times 7 minus the product of elements on the minor diagonal, which is 2 times 9. And from this, 2 times 7 is the same as 14. 2 times 9, this is 18. And this will equal to 14 minus 18, this is negative 4, which will equal to determinant y. Having obtained determinants d, dx, and dy, we can now obtain the value of x and y. From Cramer's rule, the required x will equal to determinant x divided by determinant d, which equals to determinant x equals to negative 8 divided by determinant d, which is negative 4. And this will equal to negative 8 divided by negative 4, same as positive 2. And for the required value of y will equal to determinant y divided by determinant d, which equals to determinant y is same as negative 4 divided by determinant d same as negative 4, which will equal to negative 4 divided by negative 4, we get positive 1. But before we conclude, let's use a calculator to check for the validity of the obtained value of x and y. So we go to mod, equation. These are linear equations number 1. For equation 1, the coefficient of x is 2. The coefficient of y is 5. The value of c is 9. And for equation 2, the coefficient of x is still 2. The coefficient of y is 3. And c is 7. So the value of x is 2. And the value of y is 1. Therefore, x indeed equals to 2 and y equals to 1. This in ordered pair format is the same as 2, 1. So this is the solution to our problem using Cramer's rule. To support us, don't forget to subscribe to Outek Math. Otherwise, see you in the next.